Hello again. Alright, so this is the last video. This is for level 4, learning target 9, similarity, geometry. This is for the practice for the final, for the test. Alright, so the first thing you have to do is I would suggest probably watching the video about the proof of the triangle proportionality theorem. That's what this one's about. You have to understand why it works, and that video tells why it works. So we're just going to jump into it. I'm going to tell you what the proportionality theorem is. The proportionality theorem is, or says, that if you have two triangles and you have these two lines here that are parallel, indicated by the little red arrow, those two lines are parallel. If that's true, not only can we set up this over this equals this over this equals this over this, you can actually say, matter of fact, let's write it out, uv over uw equals ut over ux equals vt over wx. The triangle proportionality theorem, let's make it pretty, states that uv over wv equals ut over tx. We are not going to add in that extra one, vt over wx, because this one here is about the whole bottom of the whole left of the triangle, the small triangle, over the whole left of the large triangle. But this part is pieces. It's this piece over this piece, and we're not really actually looking at the triangles. Matter of fact, we're going to do this one later, where they don't even have to be triangles. They're just parallel lines, and you're just looking at the proportions of the sides. Okay, so basically you were using that. Okay, so then all we need to care about is pieces. Well, we have uv, we don't know what that is, over 12 equals the distance between u and t, which is 35 over 28. We don't need to add these up this time, because we're just looking at the pieces. Then we got 28 times uv equals 35 times 12, and of course 35 times 12 is 420, divided by 28, because we're going to divide both sides by 28, is 15. This piece is smaller than this piece better be smaller than this piece. Okay? So uv equals 15. The distance between u and v is 15. Now this one here, they don't give you the little red lines, little red arrows to tell you that the lines are parallel. Doesn't matter because they tell you in words. HI, line segment HI, is parallel to line segment GJ. Now we can use the triangle proportionality theorem. 16 over 24 equals 22 over IJ. Same problem. This one here, again, you have the red arrows. Now remember, we can't determine these ones. Okay, we can't do that one. We can still, if those two lines are parallel, these two triangles have to be similar. But anyway, all right. So in this case, you can use whatever you want, right? We can use similar triangles. We can use the proportionality theorem. First thing we want to do, because it's a little confusing, we're going to want to pay attention a little bit closer. We're trying to find VW. We're trying to find that piece. Well, that means I need 3 other numbers to find that piece. The numbers they give me are 45, 30, and 22. Now, if they gave me this number here, I could use the triangle proportionality theorem. Oh, I can still use it, right? So the problem is normally I'd be looking for something like VW over UV. So just a triangle, the regular triangle similarity theorem, I would do this, and of course I wouldn't need the last one. Well, VW, we don't know. UV, we don't know. WX, sorry, Vx, we don't know. Vt, we know is 45. Okay, in order to solve one of these, we have to know 3 numbers. We have to know 3 numbers with 1 unknown. Right now it looks like there are 3 unknowns. But we can find uv. uv is 45 minus 30, so this is 15. But I still have 2 unknowns. I have this one and this one. So I can't use the regular similarity triangles. So what about the triangle proportionality theorem? Well, the triangle proportionality theorem says I take the VW over WX equals VU over UT. And VW, we don't know. WX is 22. The distance between V and U is 15. And the distance between U and T is 30. We've got 30 times VW. And then basically we know we can solve that. Okay. It turns out we don't even need for them to be triangles. We can still go, let's see, find the missing length. They want this piece here. I can go that piece that I don't know over this piece if I knew it. The problem is I don't know that piece. But you know what? I could also do the question mark over 14, the whole thing. So I can still work it as if it's similar triangles. The small piece over the whole thing. It just depends on what they give me. 7x equals, and again, it's the same concept. I want this piece. All right, that's cool. So that's the piece I want. This over 8 equals 5 over, not 9, it's 4. So you just have to be careful there, because if you put in 9, you will get the wrong answer. Now I'm just going to go ahead and finish this up because it's actually kind of interesting. That's not the only way I can do it. I don't want to confuse you, but you should know that you could also take 5, just that piece over there, and do it over question mark equals, and again you come back to this side, 4 over 8. You get 40 equals 4x, x equals 10. It doesn't matter. The thing that matters is whatever you pick for your first one, you use that same pattern. So I picked this one over here, and then I went over 8. So I went this over this. So then I'm going to go to the other side and do this, 5 over 4. So whatever I choose for the first one, I just follow the same pattern for the second one, second ratio. In this case I did 5 over, oops, and I went across this way. And then I went to the other one over here, and then again across that way, 4 over 8. It doesn't matter. You're going to get the same answer no matter which way you do. To be honest, usually a level 4 over here would actually be a word problem. The word problems are a lot more fun. It tells you why we actually care about similarity. We actually do use this in the real world, measuring things like flagpoles, the height of a tree, things like that, using the shadow in the sun. So, but it should get you good enough to get an A on the test.